Aye, Captain. 6.7 coordinate geometry. So this is the last section in our chapter for quadrilaterals. So let's see what coordinate geometry is. But before we do that, we're going to actually go through all the properties of all the shapes that we've learned in this section, in this chapter. All right, remember, proving parallelograms. You have to, if I give you a shape and I say, show me that this is a parallelogram, you have to prove it that the shape is a parallelogram by showing one of the following 6 properties. And these are all the properties of a parallelogram. Both pairs of opposite sides are parallel, or both pairs of opposite sides are equal, or both pairs of opposite angles are equal, or all consecutive angles are supplementary, or both pairs of diagonals are bisected, or one pair is parallel and congruent. You've seen this slide before. It was in the, I think, the second section of your notes in this chapter. To show something as a rectangle, you have to show that the diagonals are equal or all of the angles are 90 degrees. To show something as a rhombus, you have to show that all the sides are the same or the diagonals are perpendicular or the diagonals bisect the angles, so the angles on each corner are cut in half. To prove that something is a square, there's only one thing you have to do. You have to show that all the sides are the same and all the angles are 90 degrees. Again, that looks like 2 things, but it's one thing. All of that has to happen. To prove something is a trapezoid, you have to show that one pair of opposite sides is parallel and the other pair is not parallel. So it has to be parallel and then not parallel. And then to prove something is a kite, you need to show that the length of both pairs of consecutive sides are congruent. So these sides are congruent and then these sides are congruent. Or diagonals are perpendicular, or one pair of opposite angles is congruent and the other pair is not congruent. All right. Let's do finally some coordinate geometry. So let's say I give you 4 points. These 4. And then I say, what shape is that? All right, let's connect the dots. And then you think to yourself, I don't know. That looks maybe like a rhombus, but just because something looks like something doesn't mean you just say that's the answer. So for now, let's guess. Let's just say maybe I think it's a rhombus. I don't know if it is or not. Well, let's check out some of the properties to see if it is a rhombus or not. Here's a little reminder of what the properties for a rhombus are. I put them in the top corner in really small font. So if one of those 3 properties is true in this picture, then we can say it is a rhombus for sure. Otherwise, we cannot. All right, so you get to choose one of those 3 to prove it. I think I'm going to prove the first one. All sides are the same. So if I can show that all the sides are the same distance, then I have a rhombus. Okay, well, how do you find the lengths of all the sides? There's something called the distance formula, which you guys did in Algebra 1. All right, so there's the reminder for the distance formula. x2 minus x1 squared plus y2 minus y1 squared, and then all of that square rooted. All right, so let's find the distances. There's the distance from G to E. All right, I just plug in those points from G to E. It doesn't matter which one you use as x1, y1 or x2, y2. as long as you stay consistent. All right, so plugging it all in, simplifying it just a little bit, I get square root of 85. All right, let's go ahead and find the next distance. Let's go from the distance from E to O. Let's see what that distance is. Plugging some information in, simplifying. It looks like it's also square root of 85. So I got two sides that are the same, but that's not enough. If you look at the rule number 1, it says all sides have to be the same. So we got to go all the way around. MO, the distance from M to O, simplify, is also square root of 85. And then the distance from M to G is also square root of 85. So we just found the distances all the way around are all the same. So yes, I can conclude that this shape is a rhombus. All right, let's do another one of those. How about this quadrilateral? I don't know, that looks kind of like maybe a rectangle. I'll guess it's a rectangle. There are two properties for proving something's a rectangle. I can check the diagonals are equal, so I can find the distance of the diagonal and then the distance of the other diagonal and see if they're the same. Or I can check all the angles are 90 degrees. Since I just did distances in the last example, I'm not going to do the distance. I'm actually going to go try to prove the second property. All the angles are 90 degrees. Well, how do you prove that two lines make up 90 degrees? All right. If you remember, we can just look at the slopes. And I'll explain what that means in a second. So let's find the slope. There's the formula for the slope. y2 minus y1 over x2 minus x1. It's the change of the y over the change of the x's. Oh no, the parentheses is messed up on the bottom one. All right, so here's the slope of xy. The length of, not the length, but the slope of xy. Ooh, that's bad. The slope of xy is 5 over 2. Well, if I want to show that this is 90 degrees to this line, I need to show that the slope of yv, this one, do you remember what you have to do to show that these two make 90 degrees? It's a fancy word called the negative reciprocal. All right, so I don't know if you guys remember that from Algebra 1, but if these two make 90 degrees, then the slope for yv has to be negative 2 over 5. All right, you just flip the fraction and then change the sign, the negative reciprocal. All right, here's the slope. Ooh, it's negative 2 over 7. So it doesn't quite make 90 degrees. So my guess is wrong. This is not a rectangle. Well, if it's not a rectangle, it doesn't look like a square. I don't know. It doesn't look like a rhombus either because it's too long. So I guess maybe parallelogram. So it's okay if your guess is wrong, as long as if you figured that it's wrong, then you have to go with another guess. And so I'm thinking maybe parallelogram. So if I look at the slopes all the way around, here's the slope for VW. Notice the slope for VW is the same as the slope for XY. And here's the slope for XW. It's the same as Vy. All right, so we have these sides are parallel and we have these sides are parallel. So That is a property of a parallelogram. So this turns out to be a parallelogram. All right, so my guess was wrong. It is actually a parallelogram. Let's do one more of these, guys. This one actually says it's a rectangle. It says, show that this is a rectangle. Well, how do we show it's a rectangle? All right, by looking at one of these two. I don't know, maybe, let's see. Oh, distance formula. So I guess I'm using the diagonals are equal. So I'm looking at the diagonals to go from, let's see what color is a good color, to go from here to here and to go from here to here. I want to see that if those two diagonals are equal. So the distance from S to Q is square root of 65. Let's go ahead and find the distance from P to R, the other diagonal. It's also square root of 65. So since the diagonals are equal, I can conclude that we have a rectangle. All right. That is all we have for today. The homework is kind of scattered throughout the pages, so make sure you pay attention to the exact pages and numbers you're supposed to work on today. All right? Have fun.